Hello! Today we're going to learn how to solve logarithmic and exponential equations. And the first thing I want to tell you is the difference between a function and an equation. And the difference between a logarithmic function or an exponential function with respect of the logarithmic equation is that in the function you have y and you have x and you can sketch the graph of that. And when we're talking about equation, it's also an equal sign, but you don't have x and y. You just have numbers and x, so you can solve for the equation, or you can obtain one value of x that will make this this expression. In the second type of exercise, we have a number that is in this case -4, which is multiplying logarithm to the base 2 of 5x equals to 12. So the first thing we have to do is isolate the logarithm. So I'm going to divide by -4 both sides of the equation, and that will be logarithm to the base 2 of 5x. It is equals to -12 over -4, because I'm dividing by -4 both sides of the equation. Then you have that the logarithm to the base 2 of 5x, it is equals to 12 over -4, that is 3. And then you can express it again. 2 is the base, 3x, 3 is the exponent, 3 is the exponent, and 5x is the value. This is just 3. Let me try to erase it. And then 2 to the 3, it is equals to 8. So 5x is equals to 8. So x is equals to 8 over 5, and that would be the answer. In this exercise, I'm going to change my color. In this exercise, again, you have to first solve for the natural logarithm. So I'm going to start by writing 2 natural logarithm of x, it is equals to 3. And this 4, I'm going to subtract it in both sides. So this will be then -2 natural logarithm of x, it is equals to -1. And if we want to isolate the -2, we have to divide by -2 both sides. So this will be natural logarithm of x, it is equals to 1 over 2. And once you know that the natural logarithm of x is equals to 1/2, you can re-express this as an exponential. And so you have that the base of natural logarithm, that is e, elevated to the exponent, that is 1/2, it is equals to the result, which is x. And if you are asked to obtain the exact value, you can use the calculator of the Alex in order to do e to the 1/2. And e to the 1/2, it is equals to 1.3591. So depending on how many decimal places do you have to round your answer, it could be, if it is if you were asked to write the answer with 1,000, it would be 3 decimal places, so it would be 359. But if you have to round your answer to the nearest 100, then it will be only 2 decimal places, and that will be 1.36. The next type of exercise, you have 2 logarithms, one on the left-hand side and one on the right-hand side of the equation, as you can see. So what you have to do is first rewrite the expression with all the logarithms in one side of the equation. So this will be logarithm to the base 5 of x minus 8 plus logarithm to the base 5 of x minus 4, it is equals to 1. And then you apply the property for logarithms that said if you are sum 2 logarithms, that will be logarithm to the base 5 of x minus 8 times x minus 4 equals to 1. So that will be the logarithm to the base 5 of the product of these two, that is the first term square minus 12x plus 32 equals to 1. That is the product of these two terms. And then you have to rewrite the expression as an exponential expression. So the base is 5, the exponent is 1, so 5 to the 1, it is equals to x squared minus 12x plus 32. And this is a quadratic equation that you can solve, well, first writing the 5 on the right hand side of the equation. This will be plus 32 minus 5 equals 0. So it will be x squared minus 12x, and 32 minus 5, it will be 27. So plus 27 equals 0. And then you have two valid values for any quadratic function that has two solutions. And the easiest way to solve a quadratic function is to factor it. So if we factors, we have x minus and we have x minus. The first term, the first sign is this, and the second sign is the product of negative times positive. And then we're going to look for two values that if you multiply, you will get 27. And if you add them, you will get 12. So values are 9 and 3. And as this product is equals to 0, you can equate each of the terms, each of the linear terms to 0. And then you will have your two options, x is equals to 9 and x is equals to 3. Okay. And finally, you have to verify if those values are possible in your function. Let me change my... So we can verify, the verification is by substituting the values. So this will be logarithm to the base 5 of 9 minus 8 plus logarithm to the base 5 of 9 minus 4 will be equals to 1. So this is logarithm to the base 5 of 1 plus logarithm to the base 5 of 5. It is equals to 1. And this is the exponent to which you have to elevate 5 in order to obtain 1 is 0. And the exponent to which you have to elevate 5 in order to obtain 5 is 1. So 0 plus 1 is 1. And the second value, this value, 3, I'm going to do the verifying over here. That will be logarithm to the base 5 of 3 minus 8 plus logarithm to the base 5 of 3 minus 4. It is equals to 1. So this will be the logarithm to the base 5 of negative 5 plus the logarithm to the base 5 of negative 1 equals to 1. And think about an exponent to which if you elevate 5, you will obtain negative 5. And that exponent is impossible to obtain because as 5 is a positive number, it doesn't matter if you elevate it to a positive or a negative, you will never ever obtain a negative number. That's why the logarithms which arguments are negative does not exist. So we can discard this solution. Now we will start with the exponential equations. So the first type of exponential equations are equations like this, in which the two bases of the equations are different. So one first try that you have to do is equate the bases, okay? So if you equate the bases, you can equate 64 and 32 as 2. 2 to the 5 is 32. 2 times 2 times 2 times 2 times 2 is 32. So this will be 2 to the 5, 32. And this is elevated to the x minus 4. And 2 to the 6, it's actually 64, because it is 2 times 2 times 2 times 2 times 2 times 2. This will be 4, 8 times 2, 16 times 2, 32, and times 2, 64. So once the bases are equal, you can equate the exponents. So this will be power of power. We multiply the exponents, and this is 5x minus 20. And as the base is the same, we can say, okay, 2 to the 6 is equals to 2 to the 6, 5x plus minus 20. So we can just equate the exponents because the bases are equal. And in this case, we have a linear function, which is 6 plus 20, it is equals to 5x. So x, it is equals to 26 over 5. And that will be your answer. Something similar tests with this topic. The bases can be equal because we can see 16 as a base too. So we have to equate the bases. So this will be 2 to the x squared minus 12x plus 84. And 16, I'm going to see this 16 as 2 to the 3, because it is 2 times 2 is 4, times 2 is 8, no, to the 4. Sorry, let me erase this. 2 to the 4. 2 to the 4 elevated to the 5 minus 7x. So again, as you have a power of powers, we multiply, and then you have 4 times 5, it will be 20, and 4 times 7x, it will be 28x. And in this case, you have 2 to the x squared minus 12x plus 84. As bases are the same, as you can see, the base is 2 and the base is 2. We can say that if you elevate 2 to one exponent and it is exactly the same as 2 to other exponent, we can just equate the exponents, which are plus 84 equals to 20 minus 28x. And that is a quadratic function that we have to solve by changing all the terms in one side of the equation. So I'm going to sum 20x, 8 in this side, and here we have plus 84 and minus 20, it is equals to 0. So by reducing the terms, it will be 28 minus 12, it will be 16x, and 84 minus 12, it will be 64 equals to 0. And again, we have to solve this quadratic equation. I'm going to try factoring, because factoring is always your easiest way to solve a quadratic equation. If it cannot be factored, you can use any other option to solve a quadratic equation, like general formula or completing the squares. In this case, the factors are 8 and 8, because 8 times 8 is 64 and 8 plus 8 is 16. So we have only one solution that is repeated twice. So x, it will be equals to negative 8, and x will be equals to negative 8. So the only solution possible in this case is x equals to negative 8. When you have a logarithmic exponential equation like this, what you have to do, or what I will do, is just obtain the logarithm to both sides of the equation. So this will be logarithm to the base 5 of 5 to the y plus 9, it is equals to logarithm to the base 5 of 3. And what is the exponent to which you have to elevate 5 in order to obtain 5 to the y plus 9? Just y plus 9. And what is logarithm to the base 5 of 3? You can substitute that in your calculator. If you want, you can use the Alex calculator. This will be logarithm of 3 over logarithm of 5. And finally, to solve y, you will have logarithm of 3 over logarithm of 5 minus 9, and that will be your value of y. So I'm going to do it in my calculator. Let me see if I can. No, I cannot put the calculator here. Okay, that will be logarithm of 3 over logarithm of 5. It'll be 0.69 8 minus 9, it'll be 80 negative 8.31. So y, so y in this case, y it will be negative 8.317 in case that you were asked to round your answer to the nearest 1,000. Again, this is e to the x plus 6. So as we have an exponential function, we use natural logarithm in both sides of the equation. Natural logarithm of x e to the x plus 6, it is equals to natural logarithm of 3. The natural logarithm of e to anything is just the exponent. And the natural logarithm of 3, if you use your calculator, that will be exactly 1.0986. So this will be 1.0986. So x will be equals to 1.0986 minus 6. And that will be exactly 4x will be equals to negative 4.91 in case that you are asked to round your answer to the nearest 1,000. Okay, so what happens when we cannot equate the base and, and the base are completely different like in this case? Well, you use logarithm, you can use natural logarithm of common logarithm to the base 10. Any of the two will be correct, so don't worry, you can use any. I will probably do a different exercise with natural logarithm next. So once you have this, you can you can say, okay, the logarithm, the common logarithm of 17 to the 3x using the properties of exponents, it is equals to 3x times logarithm of 17. That actually, this logarithm of 17, it's actually a constant. And the same is going to happen here. I'm going to use x plus 6 times logarithm of 2. Okay, so this will be, if I multiply, well, I'm going to let this side as it is. And here I'm going to multiply, so this will be x times logarithm of 2 plus 6 times logarithm of 2. I am multiplying this times this and this times this, so I have the two terms. And finally, I'm going to rewrite the terms with x in one side of the equation. So this will be negative 3x logarithm of 17 minus x logarithm of 2 equals to 6 logarithm of 2. And I want you to pay attention that if you have 6 logarithm of 2, this is a constant, okay? This is a number. So as we are looking for the value of x, I'm going to factor x as a common value. So this will be 3 logarithm of 17 minus logarithm of 2 equals to 6 logarithm of 2. And finally, I'm going to solve for x. So x will be 6 logarithm of 2 over negative 3 logarithm of 17 minus logarithm of 2. And depending on your question, if you are asked to evaluate that, you will have to put these numbers in your calculator, but you can also be asked to express x as a factor or as in function of logarithm, of natural logarithm of common logarithm, so that will be your answer. In case that you were asked to obtain the exact answer, then what you have to do is just put these numbers on your calculator. And if you use the correct order of the functions or the operations in your calculator, that will be negative 0.452. Okay, like it was like the one that I asked you. It asked you to write the exact answer using either base 10 or either base e. So in this case, as I did the last with logarithm, with common logarithm, now I'm going to use natural logarithm to see, to make you understand that it's exactly the same which logarithm do you use. So in this case, you are going to use natural logarithm of 9 to the 2x. So again, we're going to use the properties of logarithms, and that will be 2x times natural logarithm of 9, and this will be x minus 4 times natural logarithm of 2. I'm going to do the product of this. So this will be x natural logarithm of 2 minus 4 natural logarithm of 2. And in this case, you have negative 2x natural logarithm of 9. So we move the two expressions with x, or with the variable that we want to solve, in one side of the equation, and in the other side of the equation we left the expression that does not contain an x, and we factor the x as a common term. So this will be 2 negative 2 natural logarithm of minus natural logarithm of 2 equals to negative 4 natural logarithm of 2. And finally, to solve the x, you just have to divide everything times the denominator. So this will be 4 natural logarithm of 2, negative 4 I mean, over negative 2 natural logarithm of 9 minus natural logarithm of 2. And that will be your x expressed in terms of natural logarithms. And basically, you can do it the same with natural logarithms or with common logarithms.